soon, it is our goal to formalize some of the things that you guys figured out when you were working with side lengths of triangles and drawing squares off of those side lengths. So as we're talking today, we're going to put all of that information into something called the Pythagorean theorem. Now, a long time ago, there was this guy named Pythagoras, and he was so cool. They had this group of followers named the Pythagoreans. And they, for the first time, figured this out. Like, nobody knew that this existed until they came along. And so we're going to talk about what is the Pythagorean theorem, how do you use it, and why should we care? Because you should care. So before we get started, let's review some vocabulary from yesterday. Take your arms, put them up like this. Okay, I'm trying really hard to have my base be straight. I'm trying really hard to have a right angle right here. Okay, oh, you guys look good. All right. We have two legs here, not these legs, but we've made two legs with our arms. Okay, you have a leg here, and you have a leg here. Okay, we're going to call this leg right here side A. We're going to call this leg right here side B. And we're going to call the imaginary line, we need one more arm, but the line that would go from our fingertips, side C. What is the other name for that? Go for it. Hypotenuse. The hypotenuse. The hypotenuse. So we have leg, this is going to be A. We have another leg, this will be B. And the hypotenuse we will call C. Okay. All right. So in your notes, we're going to quickly sketch that. Because the Pythagorean theorem works with right triangles, we're going to draw a right triangle. And your right triangle can look different, and that's okay. But this is mine. And I am going to do a little square in the corner so we know that it's right. I'm going to label side A. And that is the shortest leg. Yes, ma'am?
Does it have to be the shortest leg? Like, can you have a right triangle on the bottom and side B is like really short and then side A is like really long?
So for what we're going to talk about, we're going to call the shortest leg side A. Ultimately, it doesn't matter a lot which leg we talk about, but just so we're all on the same page, we'll call the shortest side, we'll call that A for our formula. And then our other leg we're going to call B, and that's the medium side. And it is also known as a leg. And side C is the longest side. And it is also the hypotenuse. So I just want you guys to know that because as we're working, I want us to all be on the same page. So based on the information that we saw from the investigation you guys did today, we know that if we add up a squared, so I'll just do a little sketch here. A squared, so the area of the square from side A, plus the area of the square from side B, that is going to equal the area of the square from side C. And I ran out of space there. And if that's the case, then we have a right triangle. So if A squared plus B squared equals C squared, you have a right triangle. Now, if you have an instance where A squared plus B squared is greater than C squared, you're going to have a different type of triangle. So if I sketch an acute triangle here, and I might have A squared here, and B squared here, And so it's like a squared and b squared and c squared here. Okay, so if a squared plus b squared is greater than c squared, you have an acute triangle. And so that way, if the only information you have is side lengths, you could still figure out what kind of triangle it is. If you have that a squared plus b squared is less than c squared, so you might have something that looks like this. And you have a squared plus b squared. I'm going to do my best to make a square rather than a rectangle. And c squared here, this is going to be gigantic. Okay, if that's the case, then you have an obtuse triangle. Do you guys have any questions? All right. So let's go ahead and apply this and see how this would work with a couple of triangles. So I'm going to start with number 1 here. I have a side length A of 3, a side length B of 4, but I do not know C. Yes, please add this to your notes. Thank you for asking. So if I have A squared plus B squared equals C squared, I'm going to substitute these different values in order to solve for C. I know that A is 3, so A squared is going to be 9. I know that B is 4, so B squared is going to be 16. But I do not yet know C squared. I'm going to use what I know about being able to solve for a variable. I'm going to combine like terms. So I have that 25 is equal to C squared. To get that C, yeah.
You do the square root of 25.
Yes, and the square root of what else, Eli?
Square root of 5.
I'm going to do the square root of C squared too, right?
Okay.
Yes. Do you want to keep helping me with this? What's the square root of 25?
Square root of 5.
It's just 5.
Just 5.
Yeah. And this would be C. So we know that C is 5 units. So I'm going to label it and circle it. What questions can I answer about number 1? Claire?
So if like the square root of C squared just equals C, do like the squares kind of like cancel out like the square root and the square of saying?
Yes. Yeah. So if I take the square root of something that's been squared.
Yeah.
Yeah. Isn't that cool how that works? So in this step, we would know that we would kind of think about like what squared equals, like if I have some number squared, what number would I square? And that would be 5. But that would be how you could think about doing that. All right, looking at number 2, Landon, what is the difference between number 1 and number 2? Other than the shape of the triangle. Yeah, so what are we missing on this one? Yeah, so which value are we missing, A or B or C? Yeah, so if we say A squared plus B squared equals C squared, let's go ahead and substitute some of our values in. This would be side A, side B, and side C. So A squared, we have 5, so 5 squared is 25, plus B squared, we don't know, plus C squared, if I do 13 squared, yes, sir? Me? Yeah.
169.
169. Okay. And this one we're going to solve just like we've solved other problems. We're going to combine like terms. So I'm going to subtract 25 from both sides. I'm going to give you guys a minute to solve this with the people at your tribe. I'll get back to you. 1 minute. Go for it. You are totally allowed to be chat. B squared is 20. Okay. So if we have 25 and we take away 25, we have b squared. That's all that's left on that side. We have 169 and we took away 25. What would we have, Ellie? 144. 144. Okay. Now remember that we're trying to find b. We don't want b squared. We just want b. Yeah?
You divide 2.
We're not going to divide by 2. We're going to take the square root, which is different than dividing by 2. So the square root of b squared is equal to the square root of 144. So we're going to say that b, did somebody figure out the square root of 144? Bowen?
Is it 12?
It is. It's what?
12.
It's just 12. Yes. So we're thinking about what times itself would be 124, and it would be 12. So we'll say 12 units for that one.
Would it be 144?
144. Yeah. Thank you for clarifying. All right. Would you guys like to tackle 3 with your tribe? Okay. And you guys are talking. Yes, do it in your notebook. I'm going to write some stuff up here. Okay. Oh.
We know. See you Guys, let's take it then. Yeah, we have to find out what B is. A squared.
One really cool thing I heard Tribe 1 say is, okay, what do we know already? And they would forget the information they knew and the information they were missing. So as I was walking around, I noticed that you guys figured out that B is the side length that you do not know. Awesome. So after just setting up the formula, if you could have said 49 plus B squared equals 625, gone through and solved that, and then seen that side B would be 24 units. Yes, Ryan.
How did you get 625?
Okay. Go for it.
You times 25 times 2, or just add 25 times 2.
Well, you multiplied 25 times 25. Yeah. Yeah. So you just would square that. Yes, sir.
Is this in any way related to cubers and cubes kind of doing this?
Well, we talked about
like a Pythagorean theorem of cubes?
Well, there are certain rules theorems that work with cubes. That would be an interesting thing to look at, wouldn't it? That'd be very cool. We have one more here today. Okay, I'm going to let you guys work with your group. I'm going to write some things up here, and we'll check it in about 2 minutes. Sound good? All right, let's do it. Your shadow's in the way. Sorry. No, I'm sorry. Oh, it's close. You're still filming. You're still recording. I know.
We have to find what A is. So, A, stop. 7, 3, 15.
Garrett, what did you figure out that a squared was equal to? Did somebody figure out what a squared is equal to? Megan, what'd you get?
64.
Yeah. So therefore, what would a be equal to? 8. Yeah. So this one would be 8 units. Now, later on, we are also going to talk about that you can make this a little bit easier for yourself. So, for example, on number 2, if you knew that you had to figure out b squared, you could use your formula and you could say, well, c squared minus a squared equals b squared. So you can do that as well, and we're going to work on that during the next couple of days. The last thing that we need to talk about is why is the Pythagorean theorem important? Can you guys raise your hand and tell me a reason why the Pythagorean theorem is important? And no, it's not to get into college. Why should we know how to do, well, that would be important. But why should we know that this for like an everyday reason? Megan?
So when you don't have to find like the extra side length. So you just have to find A and B and then add those together.
So we could say to find an unknown side length. Eli?
Or you can grow up and your kid is confused about the Pythagorean theorem. You teach him.
Well, that could be. We're talking about like, why would you want to know this? So architects could do this.
Oh yeah.
Claire?
If you become a teacher, you have to teach it.
Sure.
Oh my god.
So some of the big ideas are so that you can find the length of an unknown side, and you can find the length of a line segment. So this needs to be in your notes. So it is important because and I'm going to come around and check that you have something written down here, so I would make sure to take care of that. It is important because you can find a triangle's missing side It is important because you can find a triangle's missing side or the length of a diagonal line segment. Great. So please make sure that that is written down in your notes. I'm going to come around and check.